Alright, so welcome to my video on bearings. Let's jump straight into it. So let's start off with the basics. I'm very sure that everybody knows a compass and you know the general directions: north, east, west, and south. So in bearings, you should know that north is considered 0 degrees. Now, in case you didn't know, bearings is a really accurate way of saying which direction to go. Instead of saying, hey, go to the right or go to the left, you can actually tell someone to turn a certain amount of degrees using bearings. But of course, there are certain rules, which of course we're going through right now. So the first thing you need to know is, like I just said, north is considered to be 0 degrees. And in bearings, you are only allowed to turn clockwise. Clockwise is this direction. You are never allowed to turn anti-clockwise, only clockwise. Another thing you need to know, which I'm very sure that you know already, a circle, if you spin in a complete circle, it's going to be 360 degrees. All right? So, next on the list. If north is considered to be 0 degrees and we turn from north all the way to east, well, that would mean we would have turned 90 degrees. You all see the right angle here? The angle between north and east is 90 degrees. So if I turn from north all the way to south, this is a complete straight line, and if I do that, it will be 180 degrees. So you notice we are increasing by 90. 0, 90, 180. If I turn all the way to west, that would be 270 degrees. And of course, if I go from north all the way to south, past west, and head back to north, that would mean I would have turned 360 degrees. So you can think of it like this. If someone told you to turn 360 degrees, it's the same thing as not moving at all. Because if someone were to turn 360 degrees, they would turn and end up back in the first situation they were in the first place. So 0 degrees and 360 degrees will take you to the same place. All right. Now, remember, I'm teaching this topic more for the CXC examinations. We're going to assume that we don't have a protractor. In case you don't know what a protractor is, it's a little half a circle here with all the degrees on it. It's perfectly okay, but it's perfectly normal to do these types of questions without a protractor, even though we're dealing with degrees. It's more of an approximation that you have to make. So let me give you an example. Let's say that someone is standing at this point here. Let's name this point A. So the person is standing on a map and he's at point A. And let's assume that we're talking to him. And we tell him, hey, I want you to turn and walk on a bearing of 35 degrees. So that's the instructions we gave him. Well, anytime you are dealing with a bearing, you have to make sure that you're always facing north first. And we want him to turn 35 degrees. Now, obviously, if we start at north and we turn this way, the angle is going to increase to 90 degrees. Where would 35 be? 35 would obviously be between north and east. So the person would have to walk approximately in this direction. And this angle would be 35 degrees. Right? So you see, we just approximated it, right? I made it closer to the 35 because the 35 would be closer to the north than the east. It's just an approximation. Also, whenever we are dealing with bearings and we give the angle, it must always be 3 numbers. So if I say 35 degrees, I have to put a 0 here, 0, 35. That's just how they write bearings. Just get used to it. So let's do another example. Let's say we have someone standing on a map at point B. Well, We know here is north, east, west, and south, right? Now, obviously, here is 0, the east is 90. I'm not going to rewrite it. But let's say we ask someone to, hey, walk on a bearing of 163 degrees. So they're at point B and we're trying to guide them to this bearing. Well, very simple. 163 is in between 90 and 180. Does that make sense? Because here's 0, here's 90 degrees. And 163 will be quite close to south. So the person will turn and walk this direction. Let me make this arrow a little bit smaller. But which angle would be 163? Remember, bearings, you always start at north and turn clockwise. So that means that this angle here, all the way from north, all the way to this line, the entire angle is 163 degrees. So let me just ask a side question. If the whole angle is 163, but let's say I am not interested in the entire angle. Let's say I am only interested in this part of the angle. I am not interested in this part, only this part. And I were to ask you, hey, what's the size of this shaded angle? Well, it's really, really simple. If the whole thing is 163, and from north all the way to east is 90 degrees, then the remaining portion is 163 minus 90. And you just have to minus that and we'll be fine. So it's 163 minus 90, and we get 73 degrees. So this shaded angle, if they were to ask you for it in the exam, would be 73. Let's try another example, guys. All right, let's say we ask someone to walk on a bearing of 278 degrees. We know here is north, we know here is east, south, and west. North, east, west, and south. Where would 278 be? Well, north, east is 90, south is 180, west is 270, but we're going to 278. So it will be a little more above the west. So the person would have to walk in that direction, because 278 is in between 270 and 360. I know it's supposed to be a little bit closer to the west, but remember, we are just approximating here. And believe me, by just approximating, I mean, if you want to use a protractor, go ahead, but by approximating, it gives you a good visualization of the question and you will still get the question correct. So this entire angle from north all the way in a clockwise direction all the way to this point is 278 degrees. So once again, if I were to ask you, what's the size of this little small pizza slice here, that angle? If the whole thing is 278, and from here to west alone, remember, north all the way to west is 270, that means that this angle here is 278 minus 270, which is 8 degrees. So this little small shaded angle there is 8 degrees. All right, so let me erase this, getting a little cluttered here. All right, take my time and erase. All right, so let me erase this one too. So sometimes instead of giving you an angle, the examiner will tell you to walk in a particular direction. So let's say I ask someone to walk west. Well, there's no big calculations here. North, east, west, and south. The person would just simply walk that way. And by default, this whole angle is 270 degrees. If I tell the person to walk south, the person will just walk south, meaning that this entire angle is 180. All right, so remember, bearings is always measured from north, and north is 0 degrees. And the only direction you are allowed to turn is clockwise. All right, let's go through some other basic theory before we move on to bearings. All right, so let's get to something called alternating angles. Alternating angles is a it's a topic that comes a lot in Form 2 and Form 3, and it's really helpful in bearings. So here I have two parallel lines, and you know it's parallel because the two arrows indicate that they are parallel. Now, for alternating angles to work, the lines must be parallel. They can't just look parallel. There must be some indication that they are parallel. For example, if I have two lines just like this, they look parallel, but you need the examiner to indicate that they are actually parallel. You can't assume from just looking at it, hey, these two lines are parallel. The examiner has to say it in words, or he has to put the symbol for parallel lines. If you take two parallel lines and you cut them, this angle and the one behind the line will be the same. So if here's 10 degrees, over here will also be 10 degrees. So let's take another two pair of parallel lines. Let's slice them here. Let's slice them like this. So that means that this angle and the one behind the line will also be the same. So if here's 70 degrees, this angle is also 70 degrees. Now, there's only two situations I know in maths where the examiner does not need to tell you that they are parallel. It's like it's obvious that they are parallel. So, if I have a north-south line and another north-south line, and the two lines are on different places on a map, nobody needs to tell you that this north-south line is parallel to the other north-south line. It's obvious. So that means if I take here and connect it to here, since these two lines are parallel, you have a kind of alternating angle situation. So that means this angle and this angle is the same, or this angle and this angle is the same. So if here is 10 degrees, over here is 10 degrees, and if this one here is 20 degrees, then this one here is also 20. And of course, the same thing applies for east-west line. Two east-west lines are obviously parallel. Okay, so two north-souths are parallel, and two east-west lines are also parallel. And of course, don't expect the examiner to tell you that in the exam. All right, so let's move straight back into bearing. All right, so here we have a diagram, and the examiner has asked you, what is the bearing of B from A? Now, bearings are usually used to indicate positions, and you can always pretend that you're standing up on a map. Now, obviously, if you're going to pretend that you are standing up on a map, you need to know where you are standing. Now, if you're like me and your English is horrible, right? I've always struggled with English. So I had to find little tricks to figure out when I read a bearings question of where I am standing in the question. Because here there are 2 points, A and B. I could be standing at point A, or I could be standing at point B. To figure out where you are standing in this particular question, always look for the word from, and look for the letter that comes after the word from. That is where you are standing in this particular question. So I am standing at point A, and look, the dot is there. So at point A, we're going to pretend we have a compass. You notice I only wrote in the north. In most textbooks and exams, they will only put in the north. They will assume that you know here is east, here is south, and here is west. Remember, if you're only allowed to spin clockwise, and you have to assume that you are starting at north. So they want you to stand at A, and they want you to figure out the bearing from A in order to reach B. So in other words, you're going to pretend you're standing at A, and you are going to turn, and you have to pretend you're starting from north, because that's the rules of bearings, and you're going to spin clockwise, made a mistake there. You're going to spin clockwise and keep spinning until you face B. So they're asking you, what is the bearing? Well, they gave you from here to here as 30 degrees, but that's not the full angle, because bearings are always measured from north. So they're actually asking you for that purple angle from north in a clockwise direction to this line. Now here's where you have to use a little bit of common sense. If here's 90, and remember here would be east, the angle between north and east would be 90 degrees. So the full angle would be 90 plus 30, giving you an answer of 120 degrees. So the answer for this particular question is 120. But let's see if I can try to trick you, right? So let me erase this. This is a lot of clutter here. Same diagram, but I am going to switch the letters. Let's say instead of B, I put A here. And instead of A here, I put B. So this is the new question. They want you to know what is the bearing of A from B. So where are we standing in this particular question today? We are standing at B. So we're going to stand over here at B. And we want to try to face A. But there are rules. Bearings are only measured from north in a clockwise direction. So they want us to start at north and turn clockwise until we reach the line that is facing A. Well, let's use our alternating angles. Remember, here's east and here's west. Over here we have another east and another west. West-east and west-east are parallel. So if here's 90 degrees, then this shaded angle here is also 90 degrees. Now, my alternating angles. You see, in Trinidad, we usually call them Z angles. So that means this little shaded portion here is also 30 degrees, but only the little shaded portion. So once again, two parallel lines. Let me draw it here. It comes like this. East, west, east, west. And you're slicing them. So here's 30 degrees, meaning over here is also 30 degrees, right? So I hope you can see 30 and 30, 30 and 30. But they're asking us for the bearing. The bearing is the full angle. Remember, from north all the way to west is 270. So the full angle, the full bearing is 270 plus 30, making the answer for this question to be 300 degrees. All right, so let's try another question. All right, so here's another question, and we're going to attempt to draw a diagram for this question. So let's read it through. Point B is 25 kilometers from A on a bearing of 150, and point C is 35 kilometers from B. You notice I'm stressing from the word from, because that will give us an indication of where we are standing, on a bearing of 229 degrees, 229 degrees. So let's draw this diagram. Well, point B is 25 kilometers from A. So in this first sentence, we are standing at point A. And in order to reach point B, we have to walk 25 kilometers at this bearing. So where would 150 be? North is always 0 degrees, east is 90, and south is 180. So 150 will be in between east and south. So we need to walk this way, right? So let me not draw the line too long. My board here, my whiteboard, sorry, is very, very small. So if we walk this way on a bearing of 150, we will eventually reach point B. So let's write in the information. First of all, the length of this line is 25 kilometers. That's the distance we're walking or driving or sailing or flying, whatever it is. And what is the angle that's 150? Well, bearings is measured from north in a clockwise direction. So this entire red angle here, the entire thing is 150 degrees. Great. So now we have reached point B. Let's read the other sentence. C is 35 kilometers from B. So where are we standing now? We are standing at point B and we are trying to reach point C. So let's say this person walked from point A to point B and he's lost now. So now he pulls out back his compass. So it's gonna, and of course his compass will have its north, east, west and south. So he is at point B now and he wants to reach point C. So he needs to walk 35 kilometers on this bearing, 229. Where is 229? Well, north is 0, east is 90, south is 180, and west is 270. So 229 will be in between. So let's assume he walked this way. Now remember, he's walking 35 kilometers. So I'm going to make my 35 line a little bit longer than the 25 to keep it a little bit realistic. So let's assume here is point C and this line is 35. Right, so write that a little better, sorry about that. Notice this 35 is a little bit longer than 25 to keep it realistic. Right? And it will also help you get out the question in the long run. So let's put in the information. We already have the 35, but what angle is 229? Remember, well, let me clear some space here. This is point B, sorry. I'm just writing it a little way from the center, right? I need the space. The 229 is from the north, spinning clockwise until we reach this line. Remember, that's the line that will take us to point C. So this entire red line is 229 degrees. And that's the diagram, the bearings diagram for this particular question. All right, now we have I'm going to take it a little bit further because I know some of you all have reached past paper questions. The diagram doesn't stop here. Usually they ask you more questions. So let's say that they asked you, what is the distance between A and C? Now we know the distance between A and B. We know the distance between B and C, but we do not know the distance between A and C. So let's say I am the examiner and I said, hey, find the length of this purple line. You notice we have a triangle. So guess what? This topic is going to boil down to trigonometry. Now, if you haven't done all my trigonometry classes in the online classroom, which is free, by the way, if you don't know how to access the free online classroom, just contact me or send me a message and I'll send you the details. But you need to understand everything in sine, tan, and cosine, and even Pythagoras theorem to understand bearings, because bearings questions will boil down to a trigonometry question at the end of the day. Right, so forgive me if I don't go through all the theory to get out the length of this line. I'll be running through it for those who are familiar with trigonometry already. So let's find the length of AC. Well, here's some advice. Anytime in a bearings question you have the length of two lines, and we know this one is 25 and we know this one is 35, always try your best to find the angle in between those two lines. So the 25 and the 35, I want you to find this entire angle. And here's the nice thing. To find that angle will most of the times be common sense. So it's a very easy task. So let's go about this. I'm going to show you how to find the length, the angle from here all the way to here. Great. So let's use the alternating angles theory. Remember, from here to here is 150. What's the angle from north to east? North to east is just 90 degrees. So how much is this remaining angle here? I'm shading it here so you can focus on it. It should be 150 minus 90. So let's do that. 150 minus 90. And this angle here alone, the shaded one, is 60 degrees. So, and I'm not too sure if you can see the Z angles here. Here we have a west-east line and a next west-east. So you see a little Z angle here, or alternating angle. Let me draw this back here. It's kind of hard to see sometimes. If here is 60, then this angle is also 60. So that means from here to here only from here to here, not the whole thing, from here to here is 60 degrees. Okay? So this is what we know so far. If we were to figure out this angle here and add it to the 60, then we would have the entire angle. And finding that angle is going to be really easy. What is the angle from north all the way to west? Let's talk about this. Let's draw this here. If here is north and here is west, from north all the way to west is 270 degrees. Remember, this red line is only going up to 229. So the red line from here to here is 229. So imagine you're running a race and the full race is 270 and you only ran 229. How much is the remaining amount in the race? You just have to minus these two values. So it's 270 minus 229 and you will get 41 degrees. So this little angle here is 41. So if we add these two, we will get 101. So the full angle is 101. 60, let's double, 60 plus 41 is 101. So I really hope you understand the common sense over there. Please rewind it if you don't understand it. So remember, the aim of the question is to find the length of this line. I haven't forgotten. But once again, once you have the length of two lines in a bearings question, use common sense and reasoning to find the angle in between. So this diagram looks crazy, looks complicated. Let's draw it back with only the necessary pieces of information. Here's A, here's B, and here's C down here. Remember, the aim of the question is to find the length of this line. So let's put in some information. We know here's 25 kilometers. We know here's 35 kilometers. And we know the angle in between is 101 degrees. And we want to find the length of this line. According to the trigonometry videos, when you have the length of two sides and the angle in between, that's an excuse to use the hard sine rule. The hard cosine rule. So capital letters are for the corners, they represent angles. But if here's capital A, this side is common A, here's common C, and here's common B. So we are already trying to find common B. So using the hard cosine rule, B squared is equal to A squared plus C squared minus open brackets 2AC cos capital B. And we just plug in our values and square root it. Let's see what we get. B squared is equal to A squared, 35 squared plus C squared. Right, I'm taking the value straight out from here. 2 multiplied by 35 multiplied by 25 multiplied by cos 101. Remember, this capital B represents the angle. So all we have to do is, what I showed you in the previous videos, you just type in this long sentence here on your calculator and then throw across the square to get the square root. So the final answer for B, let me work it out here quickly. 35 squared plus 25 squared minus open brackets 2 multiplied by 35 multiplied by 25 multiplied by cos 101 close brackets square root, and the angle, the length is roughly 46.7 kilometers. So this length here is 46.7 kilometers from C to E. Alright, so I really hope that this is actually a past paper style question, right? We don't make you draw the diagram and make you find a missing length. Okay, alright guys, So I really hope this really explain the bearings. Of course, if you need more clarification on this topic, just leave something in the comments here saying, hey, you want different style of questions and bearings, and I'll be happy to make a video. Take care, guys.